My name is Jasmine.Darby. I teach at Hines Lakeview Charter School in New Orleans. I am most passionate about building relationships with my students to impact their success. I have a fifth grade class of 28 students. I have 3 diverse learners and 5 students who receive 504 accommodations. The lesson you will see today is on multiplying fractions by a whole number using Eureka squared math. In the previous lesson, students multiplied fractions using a number line. I prepared to teach this lesson by reading the why, taking the upcoming quiz, annotating the problem set, and identifying my students' areas of struggle. I adapted my lesson to reach all learners by using heterogeneous grouping, small group instruction, tape diagrams, and number lines.
Show me on your hand with your fingers. Show me 1/3 of 6. Show me 1/2 of 6. Show me with your finger. Half of 6 is 3. Have 4 parts. Why do you have 4 parts? Okay. And why do you have 9 as a total for those 3 parts? Okay. Think about another strategy you can use besides that tape diagram. I want to see more than just this tape diagram. I'm going to pull a stick. Come on up and show me what that looks like. Zoe. Because that was a different strategy. I saw tape diagrams on the other groups. So tell me about this number line. This number line is split into fourths.
Because it says that 3/4 was $9, and then I split it, so that would be
Which part of our fraction would let us know to split that into fourths? Go ahead and shout out and tell me. Okay, so my denominator lets me know that I'm only showing 3 out of the 4 parts. Okay. I want to add on to this diagram so that I can clearly see that 3 out of 4 parts equals $9. What else could she do?
because 1/4 equals 3.
But how do we know that 1/4 is 3?
Because if 3/4 is 9, then the only way to get
Sure, you want to do a different strategy? That's fine. And then maybe we can use this strategy to go ahead and add on to Zoe's. There's a division because, thank you, you can have a seat. 9 divided by 3 equals 3. So what can I do on Zoe's drawing to show $9? Sean?
We could break each part up into thirds.
Okay, before I break each part into thirds, I need to identify those 3 parts equals how much? Equals the $9. Went ahead and did her division, and I can see in this diagram that 3 plus 3 plus 3 equals 9. Now how do I get to my answer? What am I looking for? How much money he started with. Go ahead and discuss. How can I add on to these diagrams to figure out my total? 9 plus 3? Okay, can you go write that on the board? So I have one equation that can work, another equation that can work. Can you?
9, there's 9 3 left, and 9 plus 3 is 12, and if you take away this 3, then you have 3.
Okay, thank you, Jay. I'm adding 2 points to your team. Is there another equation that I can make? What do you see repeated? Tell me.
3.
How many times?
4.
What's another equation I can make, Jackson?
3 plus 3 plus 3 plus 3.
Okay, 3
3 times 4.
3 times 4. Perfect. equals 12. Please ask your partner, how many groups is each whole partition in? So how many holes do you have?
Two.
How many? Let's look at our number line. Do you have 2 holes or do you have 4?
We have 4 holes.
Okay.
Yes.
And tell me how many groups are in each hole. Do you agree with that?
No, we have 3 groups in each hole.
How many groups do you have in each hole?
And 1 half. It's over 2.
Okay, so why 2? Can you show me that you have 2 groups in each hole?
The answer is
Can you show me that you have 2 groups in each hole?
you would shade in 1. So then that would equal 4.
Okay, so I see
4
1,
halves.
2
So then we would
in
divide.
hole number 1. How many in the second hole? Show me. Now, are you supposed to be shading in double? I only want to shade in how much out of each hole. Look at our problem. Okay, so you should only be shading 1 groups do you have in every hole.
We have 2 in every hole.
Can you show me? Can you count for me?
1, 2, 1, 2, 1, 2, 1, 2.
Okay, and then how many should be shaded out of every hole?
We should shade 1.
It was
2.
because you
Simplify. No. Divide.
you divided by 2 because we know that fractions are really division. Okay? Now, let's look at our product. Our product is 2. What do you notice about 1 half of 4? Is 2 greater than or less than our total? Talk about it. Is 2 greater than or less than our total?
It's greater than.
So, what is it? Greater than or less than? I'm hearing greater. That number 2 is less than our total 4. Why do you think that is? I have half of 4, which is 2. I know that 2 is less than 4. Why do you think that 2 is?
Because we're multiplying by a fraction that's less than the denominator.
So I'll let you find your product, and then we're going to talk about if our product is going to be less than 4 or greater than 4. So I have 3/4 4 times. And what's the final answer? How many fourths? How many total fourths? 12 fourths. 12 fourths, which is the same as 3. Is 3 greater than or less than 4?
Less.
3/5 of 13 is 3 parts, and 15 is partitioned into 5 equal parts. Excellent. Go ahead and write that and fill it in your blank. 3/5 of 15 is 3. Did that work? So now we're just going to use and take that 1 part and then 4. Can I break my total down into equal groups or into 4 with an equal number inside each group? Yes, I can. So if I can do that, a different way to write this problem, 3 times 60 fourths. Now you do the work of finding 60 fourths. Get started. I'll wait for you to get that division done. And when you have that number, shout it out to me. 15. And you went off to the side to do 60 over fourths, right? All right, so 15. And some of us remember we have a full clock of 60 minutes. If I take each part of 60 minutes, 4 parts, how many minutes inside each part? So you have 10 minutes to complete number 7, 8, and 9 independently. I'll be pulling some different people. If I have 6, can I break that into equal groups with 9? Okay, why not?
Because 6 can't go 10.
Okay, so I can't split 6 evenly into 9 groups. So is it necessary to change this one to 6 ninths? You agree with that, Jade? 5/1? So remember, you just told me that I don't have a number big enough where I can split that number evenly into 9 groups. So I'm just going to leave it as is, right? So if I have 6 groups of 5 ninths, how many total ninths do I have? Ninths before I get there. Okay, so can I rewrite 7/8 times 64 as 7 times 64/8?
Yes.
Why would it work this time?
Because 64 can go into 8. Because 64 divided by...
Problem? Bring your pencil. And where did she get this 8 from? From the denominator, so she just brought this 8 down?
Yes. I got it from the...
You agree?
I got it
Is
from
that what you got that? 64 eighths. 64 divided by 8.
I think it's 56, but I did it different.
Go show me your way that you did it. So tell me, what is she doing in her example?
She's doing 448
But how did she get that?
She got it by 64 divided times 7.
Okay. So thank you for doing that long work. I appreciate you multiplying and then dividing. But guys, if I can change it to 64 eighths, I can just rename 64 eighths as 8. And that cuts out all of this work. But thank you, Jade, for doing it. What about a whole number that is not 0 multiplied by a fraction that's less than 1? Think about the product. Is the product going to be greater than that number or less than the number? Look at this example. Discussing your teams, you have 30 seconds. Go.
That's because
Can you give me an example? What's any number less than that? Okay, what's half of 18? I heard from this team. Does anybody here want to share out about the product? If I have a number that's not 0, okay, a whole number, multiplied by a fraction that's less than 1, will that product be greater than or less than that number? Together, greater or less than?
Less than.
Okay, can you tell me why, Brennan?
Because say 1 times 18, that's 18. So if you have anything less than 1, it'd be less than 18.
Okay, you said 1 times 8. Notice I said any number that's not 0. What if I put 0 there? Thomas?
Just get 0.
Okay, so any fraction, for example, let's keep that fraction 1/5. Anything times 0 is what?
0.
Okay, so anything times 0 is 0. And you said 1 times 18 is 18. Now, how would I get a fraction or a product that's less than 18?
By using a fraction times 18.
Okay. Any fraction? Okay, so any fraction. I
A
can
fraction
use-
less than.
Any fraction
I can
less
use-
than the denominator.
The numerator has to be
That would be greater than.
So this fraction.
That would be greater than. That would be
Well, then what's 10 fifths?
10 fifths is 2.
So that's 2 times 18. That would be double 18. So only when my numerator, I heard you say it is.
Less than the denominator.
Okay, so look at this example. 1/5 times 18. One more that would give me a product that's less than 18. Brendan, 3/5. Okay, why would 3/5 work? 3/5 is less than the denominator?
Well, 3 is less. And numbers higher than the denominator.
Such as 10/5.
Yes, so that means it's higher than the.
Okay, so it's bigger
My goal was for 80% of my students to score 90% on their exit ticket. Next time, I will reduce the allotted time given for partner work to spend more time on independent practice. After the debrief of the lesson, students completed an exit ticket to assess their understanding. 85% met the goal.